Hello everyone.
Okay, hello and welcome. So tonight we're very close together tonight, so we're going to wear our masks tonight. It's a bit cold here in Germany as well, so we're not able to keep the windows and stuff open. So yeah, apologies for that, but it's a sign of the times at the moment. So thanks very much for joining. Tonight we're going to have a look at our third of three webinars, and we're going to have a look at high voltage batteries. So my name's Daniel. I'm here together with
Bernd.
Bernd is the product manager for automotive here at Lucas-Nuelle, who designed and developed the training system that you're looking at tonight and what we're going to go into with great detail. So we've got the perfect man for the job. So just as we're over the last two nights, if you're a part of the California Automotive Teachers organization, you will be able to apply for your certificates, or we'll send out some certificates to you at the end of the training. The training we're looking at, we've planned for 1 hour, and it could be that it goes for a bit longer than that. So Bernd gets a little bit crazy when it comes to high voltage batteries. His expert doesn't really say enough. So, but we're going to plan for an hour, but it could go for much longer than that. If you're there, great. Stay with us if you can. Otherwise, we are recording this and we'll put it up onto YouTube over the next couple of days. So you'll always be able to catch up there as at a later date. So,
Okay.
High voltage batteries. So we've seen that electric vehicles are becoming more and more popular now. Yes. Hybrids have been around for a long time as well. But electric vehicles are becoming very, very popular. Of course, the size of the batteries are increasing.
More and more.
Bigger and bigger. And so it's kind of one of the points too where we're seeing that's the points where electric vehicles are becoming critical is the batteries degrading over time.
Yeah. Especially the voltage level goes higher and higher. And nowadays up to 800 volt, that's a mass of voltage. So
that's pretty crazy.
Yeah.
So high voltage, we're talking about high voltage. High voltage starts at
60 volt.
60 volts DC. Yeah.
Of this level.
So it's considered. We're actually starting to see some hybrid vehicles at 48 volts.
Yes.
Which they do that deliberately to stay under the high voltage section. So there is some of the newer vehicles with smaller motors. But what we're talking about today is high voltage batteries. So would you like to give us a quick introduction to the system? Is this a real high voltage battery, for example?
Yes, that's a really high voltage battery. Here inside we have two modules, one on the right side here, and the one module with 8 cells on the other side. In total, 16 cells controlled by the BMS. And for the details, we talk later about, go into the details and talk more details.
So it looks a bit funny here. You've got cells. These look like the cells that we know from Tesla, for example, 18650. Or is it just a plastic case?
No, it's a real cell, and I think later when we maybe disassemble the cell, we can show the cell themselves and measure on the cells so that we can see, yes, it's a real cell.
So inside you actually have 18650 cells, but there's a little bit of trickery and magic inside in order to get the monitoring and fault finding and things like that.
And also the extra protection circuit that we can really work on it.
And why is this so important to have high voltage battery, an understanding of how they work and being able to swap the cells, for example? We know here in Germany, for example, it's now the manufacturers are starting to say you can't just send a huge lithium battery all around the country to we know that from...
The transport is also a big
exactly.
topic.
So we know that from earlier days with the Prius, that's the common one everyone knows. You would just send the battery away, get it repaired, come back, and you would then fit that at the dealership. But with the lithium batteries, they've said, no, that's not possible. You're not sending 20 to 100 kilowatt batteries around in...
And especially when we have some troubles with the car and delivered a battery, that we don't know what's really happened inside,
Yeah.
and we have to send it. That is
Becomes very critical.
yeah, really critical.
So here in Germany, and I think you can expect to see that soon in America as well, that the manufacturers will start saying you need to repair these batteries in the workshop.
Yeah.
So at the dealership level.
Yeah.
We're starting to see that, and it will become
Not
more and
each
more
workshop, but the main workshops more and more get to enable to repair the battery by themselves.
So that's the reason why we developed this system. This system's being used by, I
We
think,
need more specialists that can do these repairs.
Yep.
So,
and here we've got, I think every German manufacturer is using this system. A lot of training organizations are using this as well in order to get their technicians trained up.
Yeah.
One of the things, for example, we spoke with the guys, the head trainers from Audi here, and they said, we can get cars to do the training, but do you really think I'm going to be putting faults into a high voltage battery on a brand new vehicle which has to be sold again 6 months after we finished our training?
Yeah.
I said, no way. So
it's not possible.
they have to try and do the training without an actual high voltage battery. And so things like that, whereas they decide, okay, this is a way that we can skill the people up to make sure. But we're not trying to do a product demonstration here. We're trying to do some training. So we're going to have a look at the fundamentals of high voltage batteries. Yeah. So maybe what we'll do here is we'll just have a look bound. Yeah. What are high voltage batteries, and how do we get high voltage from a battery, for example?
Yes, we need a really high voltage level. Each cell have around 2 to 4 volt each cell, but in the end we need up to 400 or 800 volt, so we have to build stacks to build some.
So if you look at that cell level, we start talking about cells in series here. Yeah. And so we can see here.
To increase the voltage level.
Yeah.
For example, 3, but 3 of 300 in series. So.
Exactly.
But when you understand how works 3 cells together, then you can imagine how works 300 cells together.
And this is what they've done in a lot of the older early hybrids. They used series, just every cell was in series. But we know from the older hybrids they weren't.
The range.
The range was literally 1 to 2 to 5 miles maximum. Yep. So that's where we also need then to increase the capacity.
Now we can see they are in parallel, so we can edit the capacity 2 ampere hours, 4, and all together are 6. And so we build the stacks in parallel and then goes one step later when we...
This doesn't affect voltage though at all, does it?
Yeah. In this...
So a lot of the systems now are actually a mixture of series and parallel together.
Yeah.
So that's where increasing capacity plus also the voltage.
Yeah. And sometimes when I read on the battery label, I can see it. For example, this is 2S 3P. Mm-hmm. 2S 3P. When you see on the big label, you see 45 S and 8P, and so can you see that is 2 in series, also 2S and 3P.
Okay.
That is the logic behind the short sign.
Okay. So we've had a look at, say, the typical voltages. So the voltages really vary hugely now. So roughly from 100 volts is the lower end, right up to now the new Taycan is at 800 volts.
800.
The new Hummer that's going to be released next year is also at 800 volts. So it's becoming, we see the tendency for more power. Does it have an effect on charging as well? The 800 volts, I think they can then charge more and faster with
Yeah.
higher voltages.
It's also a topic, fast charging. I think it's not for today, but I think in another video we talk about fast charging. Fast charging is a really hot topic because when I charge so fast, I have to cool down the charger, I have to cool down the wiring, and I have to cool down the car during the charging.
Okay.
So it's
So we're just going to go into a little bit of the theory just so that we can continue on and show how there's different types of cells and batteries that are made up. This one is the one that everyone knows about, the Prius. And so what we're looking at is cells, and each of these little slices here is what we call a module and the pack. So you get that same cell, module, pack.
And you can see every second cell is turned 180 degrees before when they fly in the bridge connectors.
Yeah.
In the end
So
came the bridge connectors. And you can see they built one long snake.
Exactly.
Here comes the snake. All two, so that all in series, like a snake.
And on the opposite side, they would then be on two other connectors.
So,
And this here, another important point, is the where the service plug goes. Also something interesting here.
Yeah. The tiny wires are for the voltage monitoring. We talk later about more, this one. Yeah, okay.
Okay, so that's what we call a prism cell.
Yep.
And that's the type that you find in the Toyota Prius. We also have the cylindrical cell. This is like the old school D-size battery. This is a lot of the old Ford Escape had this,
Nickel
for example.
metal hydride.
Yeah,
batteries.
nickel metal hydride. So important thing there is, we'll talk about this just a little bit, I think, not too much, but the different type of batteries. So you just said nickel metal hydride.
Yeah.
Obviously we know about lithium now as well. Lithium is in any type of plug-in. So if the vehicle has a plug where you can charge it, it is now lithium. If it's one of the older type hybrids, it's usually without a plug, it's nickel metal hydride.
And also the voltage level, you have only 1.2 volt for each cell. So when you reach 100 volt, you need a really long stack.
Yeah, that's true. And these here are all in series as well. So if you're able to see that up close, it starts at one end and goes all the way through down one side, and at the back here it connects through and then through there. So all of those together for 300 volts.
Yeah, but there also exist lithium cells in a round version.
So the Tesla cells, of course, they're much smaller. This is the 18650, which basically became famous as a laptop battery. And there's literally thousands of these in a Tesla, and they're slowly, or rather fast, moving on from these type of batteries. They're now at the 2170, so they're getting bigger, and now they're even looking at another size, which is closer to a can of drink or something like that, a huge cell.
Yeah, and so more capacity.
Much more capacity,
Also.
Another type of cells here that we know about are the pouch cells. Yeah. And these are also, you can see here with the tabs up the top, and they can be found in either series and parallel together.
Packet also in the such modules.
Yep. In the Chevrolet system, also using pouch cells. And one of the things that we can see here, as they degrade, they can actually get gases building up inside and push the battery pack apart. So another little thing that we got here is the protection. So we've seen that batteries need to be protected.
I think especially the lithium cell needs protection.
Yeah. So this has a couple of things going on here. This is a fuse inside the service plug. Yeah.
A main fuse, and they blow up. The whole system are blocked and also protected by an interlock.
The interlock, exactly. But if we have a look here also at the
Tesla configuration.
This is what we got, they call this a wire bonded cell. and there's tiny little wires connecting every single one of these. And this piece of wire that you see up here, that one there is called a current collector, and that's where, so you see that on some of them. So all of these on that right-hand side, that would be the positive, I think, bound with the in the middle there.
Yeah, the positive.
The positive, and on the other side here would be the negative. So that's within one module. So we can say there that that is in series and parallel.
Yeah, a lot of cells parallel, and these are in series. Yes, we need more protection. We talk about that. Maybe we can talk about the voltage level.
Okay. Oh.
Okay.
The reason why we have
protection.
Yeah. You can see here. Yeah. I think the technology has gotten better. It's not so bad now, but there was obviously a lot of problems with lithium cells that could,
especially when the sealing broken and so on. Yeah.
Yeah.
In the case of an accident, maybe it's also possible that when came an impact into the battery block. So. Okay. Let's go to the different level. I think we have to talk about that the cells are physical tiny difference between each cell. We have a lot of cells, and each cell have a bit more or a bit less capacity. And what's happened when we have such a difference between?
Okay, so in balancing?
Without balancing, we're balancing.
Yeah, okay. Well,
why we need balancing?
Okay.
So topic we come later on it.
So if we have a look at, for example, let's just put some cells into series here. So if we have a look here, if those cells were running along in series, we know the amount of current running through is running through all of those at the same time. So, and once we get to the point where certain battery is depleted, that is the moment the vehicle basically has to stop. Or you can risk damage to the cells.
Especially lithium cells are really sensible for that. Sensitive for that. You don't have to over discharge or overcharging, so you have to protect that. In this case, we have to stop. Otherwise, the battery cell goes damaged and decrease the capacity more and more. So we have to protect this situation. But you see, there is a lot of energy left in the other cell. So, but we can't use that because we have one cell that is too low and we have to stop.
And that's, for example, where we talk about high resistance of a battery cell. This is one of the problems that can cause that.
And also on the other side, when we load the battery,
charge
the battery, you know the battery before, the battery was only half empty, or half full. So, and then there is the first that is full up, and then we have also to stop. They're also in series, and we can't load the other cells without charging we can't charge this cell without charging it. All in line, all current that flow here goes during all the cells. So
we can then have problems with overcharging without BMS. So that's why BMS, battery management, is so important.
Okay. So as the solution is?
That's what it looks like without BMS. And this is what it looks like with BMS. So, well, balancing.
The same situation as before, yes.
So there's a lot going on. This is obviously a very simplified version.
Simplified is good. We have a resistor to discharge each cell and a switch. In our animation, we have a manual switch. In real, it's an electronic switch and controlled by the BMS. But in the end, we have an electronic switch, and they switch a resistor that
it's watching over everything, which is, so there we can see.
Same situation as before.
And that's normal for lithium cells to get out of this want to say get out of whack of each other. They're a little
Yeah.
bit different from each
Yeah.
other. It's basically
Yeah.
normal. It's going to happen, especially when you've got lots and lots of them. But here, the interesting part is once we get to the point where this one has now
It's
up to
full.
its full, it's
In
ready.
the situation before we have to stop charging, now we can charge again.
And so the current, instead of going through the batteries, is now bypassing through the resistor internally in the BMS system.
And on this way, I can charge each cell perfectly up to the maximum.
And so perhaps what we'll have a look at here is
Yeah.
get the system
Can we see?
started.
Yeah. And now we try to show this situation on the real system.
There's a question in the chat.
Question in the
Let
chat.
me just bring up the... Okay, we have a question there. What does BMS stand for? I think we mentioned that. Battery Management System. We don't get the chat here. Oh, hang on. Chat.
Do all hybrid electric vehicles use BMS or just specific vehicles that use lithium batteries?
I think they use
Oh,
some sort of BMS.
Yeah,
So
as-
there's,
I think no electric vehicle works without a BMS, but especially the lithium powered systems have to have a BMS system.
it comes down to what is the
BMS.
information inside, or what is being
Yeah.
processed and controlled by the BMS. So you're going to use the BMS to control
Yeah.
the system main relays, for example.
Yeah. We
Maybe
can
to read the temperature, but there's not so much that can happen as far as...
The best way is we show it on the system values, and now we start the tester and go with the tester into the voltage monitor.
And the reason we've got the scan tool built in here is because we know that if we put an OBD plug here, scan tools are often a little bit hard to come by for
Yeah.
high voltage batteries. To go
Yeah.
into this level is actually not so common. Okay,
Okay, now we see the voltage level is nearly the same. Each voltage stands for each cell. Here we see right voltage 8 voltage information for these 8 cells, and these 8 voltage information are for these cells. And when we see there's the green light for high load, but when they go from the from the bright green to the dark green, then if this the moment there comes the resistance up.
so that's the internal battery balancing occurring inside. As that's
Yeah.
blinking, it's showing you, okay, that's entering into balancing mode internally.
Yeah.
There's an important difference between internal balancing and external, because we're going to show you what external balancing is as well soon. So we're going to let that run for a little bit, because at some point soon, as this gets into
Yeah.
4.15 over everywhere, 4.16, then all of the different systems are going to start blinking in and out as well.
You can see one cell is 4.13, comes up to 4.14, and when they enter the 5,
Maybe
Then
what we'll also have a look at while we're waiting for that is the other thing that's being
Yeah.
measured. So there we had voltage and current, and one of the other important things
Is
here
temperature.
is temperature as well.
so our BMS controls overcurrent, we protect the current,
Yeah,
we protect the voltage to
And the temperature.
see, and the temperature.
yeah. There's also usually a overview of the system as well. And so here you can see average cell voltage, maximum and minimum cell voltage, the complete module voltage, what it is on each side, and then of course the state of charge. Now we've deliberately put this up to 100% so we can show the balancing, because that can take quite a while to get the balancing occurring. It really is at the top level when the batteries are completely full.
Here displayed the current in the moment 0.8.
How is the current measured on systems, on batteries? Do they use a virtual, or are they using an ammeter built in? Like, are they measuring the physical?
It's a good idea. We have an IT network, means the whole battery system, the whole high voltage system is isolated Terra. It's independent from the rest of the electrical system of the car. So, and we have also we can't measure inline. When we measure inline, we have potential equalizing between the systems. So we need to...
So that, you mean where the scan tool is connected is part of the low voltage system.
The scan tool?
If you're measuring inline of the high voltage battery,
yes,
to measure, to read out that, it then, or not really?
We have it wireless. We have to measure it wireless with an Hall sensor.
Okay.
That can measure the current exactly, but without a physical contact, without an electrical contact between the high voltage system and the low voltage systems.
Okay.
Yeah?
So here we see the balancing starting to occur on a lot of different cells now. So you can see the blinking in and out. So that means they're absolutely jam-packed.
Yeah.
And the system recognizes that, and it's bypassing those cells.
Equalize it.
Yeah. Okay.
So when it's full up, they're stopped.
So we're still running at some current, but eventually it will also
It's a reduced current.
Much
it's
reduced
not full.
current.
It's
If we've seen that at a different point, it goes up on this system for 2 amps. Is that 2 amps per module?
it's all in line, so 2 amperes for all.
For everything, okay.
For every cell, yeah.
And so that alone is quite interesting to see how the balancing happens internally as well. Okay,
But
so...
you have the chance to see that.
Yeah. So we talked about some of the faults that we see before would be, and we mentioned it, high resistance in the cell. I always find that interesting, high resistance in a cell, because it's a battery. They tell you to, if you're going to measure resistance, you need to remove it from the power supply. It's a bit hard to remove a battery from the power supply because it is the power supply. So that's something that you have to do virtually, or you have to calculate the resistance in a cell, don't you?
You can calculate the resistance.
So using Ohm's law, you can go around the opposite way. You know what the voltage. We can then work out the current and then calculate what the resistance would be.
You can see in the moment we have a proper system, everything is fine, and we have, without any loads, we have 4.03 volt, and then when we set the system under load, everything has to be fine, or not. So we have to take care of the voltage level. The maximum difference between the cells is 150 millivolt. Also 0.15 volt is the maximum difference that is allowed. Otherwise, we get a fault. We get a fault. Okay. And when we see on the display, we can see everything is fine, but...
And so that's also interesting because we noticed before during charging, that one was blinking much earlier than all of the others as well. So we know that when the resistance is that we're seeing it's much lower under load
and much higher during the charging. Yeah.
Okay, so that's interesting. Should we check what would the first thing you would do here, for example? Well, actually, before that, something that I find interesting is if you were to have a look at the cells, if you just took the battery out of the vehicle, now it's going to make a liar of me, it's been doing it all day, but if you had to take the cell out of the vehicle already, sorry, the whole battery, and you just measured the voltage, here unfortunately we can see there is a difference, but you certainly don't see the difference that we've seen before, which was there was almost half a volt difference between the cells during putting the system under load.
You have to see, Ohmic law, you have to see 4 amps discharge current and minus, in this situation, minus 2.5 amperes.
Yeah.
And without load, you couldn't see the difference. And that is the reason why we have to check it out before we disassemble the battery.
That's really important.
Before we work on the battery. When we have the battery out
It's too late.
of the car, it's too late.
You can go along and load each and every individual cell, but it's much better off doing it inside the vehicle first and noting all of these things down, saving all of that information, and then you've got something to work with when you actually want to look inside the battery. So,
yeah, when you see the cell 11, you have to see here's a slot 11.
yeah,
16, 15, 14, 13, 12, 11. We have to control slot 11 is also inside, correct?
Yeah.
Also the cell 11.
So
Okay.
what we're actually going to do now is do a cell swap
Yeah.
and including external balance.
Yeah.
So now external balancing takes a little while, so we're going to show you that straight away.
Yeah.
So
Okay.
perhaps if you
Before you-
go out
I
of
think-
screen share for
yeah.
a second, just so we
Yeah.
can see that in a little bit more detail.
Yeah. What then you mean is before we can change the battery, before we can swap the cell, we have to make sure that these cells have the same voltage level as the cells inside of our systems.
Because you're buying these, let's say you
So-
buy these brand new,
It's
And
normally
you buy
in the
them from a
storage level,
they could come at any different voltage.
yeah,
So
in the
these
range
ones-
of 3.3 up to 3.9 or such.
And if
like
you're looking
this.
at the Prius, for example, where it's got 6 cells in there, then you might see some sort
Yeah.
of difference.
Okay,
That becomes critical because when you put it back into the vehicle, if the range is out of range, you'll start tripping fault codes
and the
immediately.
fault codes is the lamp is still on. So I have a problem.
Yeah.
So this cell is different, but he only notes the voltage difference.
So what we're going to show you is the cell balancer that we have here.
Yeah.
And
Okay. Okay. The cell balancer. Before we go to the cell balancer, let us show where we can find the information. How high has the level to have? Which level we need? Yeah. Okay. We see here the voltage are a bit different. For this, we can use the NAVA display, the system monitor. Here we become the average. Yeah. And the average voltage level is 4.06. That is what we have to remember later when we go to the balancer. And now I want to show the single cell balancer on the table here. This is a brand new system, additional equipment to repair electrical cars. So now we have the possibility to bring this cell up to the right level. We can we can bring it here on the front. We have to connect it. Now what we can see is, now he find out is cell number 17. We talked about before, each cell have numbers from number 1 up to number 16. And this is the replacement cell, get a new number 17. Okay?
so this is just something for the training system. You wouldn't see this on a real vehicle.
In
This is-
the real car is also a number on it, in the barcode, and there's a huge number, 4 million, 4,000, whatever. But each battery cell have an individual number, yeah? And when we make it simple, we say we have 17 cells, we count up to 17. So, okay, but it's similar to the real world. So now we have to fix it, because we want to discharge the battery. Next step was to screw the terminals from the battery.
And so this is a little automated machine. This is actually a prototype that Bound has been working on. So we're actually now taking this into development, and we'll be developing this system in the coming months. But this is going to show you what the balancing is, all to do it automated. So it's going to measure the voltage and charge the system according to what's
And now
required.
we have also plugged in the protection cover. Also the temperature was here checked out during the charging. And now we can see the voltage level. When we look on the display, we can see cell, and then we can see the voltage level 4.05. And which level we need? Can you remember?
That was 4.06.
6, not far away. So we have here the jog dial. We push on balancing. We also can test the cell, or we go to the balancing. And now we can choose the target voltage up to 4.6. Okay, now we press on the button. Then the question is confirm the target voltage to 4.06, and we say yes. And now the balancing procedure is starting. You can see
So
the current.
with a small voltage change, that won't be a long process, but that could take up to say half an hour for if that was say at 3.7 volts. Or
Now we are lucky that it's not far away,
yeah.
so we need not so much time for that.
Okay.
Okay,
So what
Good.
we'll do then is
and
perhaps
we use the time.
to remove the new or the old cell from the system.
Okay, before we open the battery, we have to de-energize the system. That for this situation, we also use the tester.
Let me just screen share that again.
Okay. 06 special function, and then high voltage isolation procedure. Now we get a warning. Okay, we say we are trained on this system, we can work on it. Then we have to check out which equipment we need. There was a safety padlock, like this one, and a printed form with warning levels. We have here some red label and the white label. Okay, we have all. Now we can continue. Then we have to say, okay, now the system is under load. Then it stands here, switch the ignition on, please, not ready mode, okay? Switch off the system, and the next press bring me up to the ignition on, okay? Then next step, by the arrow to the right. The system still not free, please show on the display. Here on the display, we can read HV system still active. Okay? They do the same as we do. They check his own measurement equipment in this time.
Bernd, last night we heard from gentleman from Volkswagen in the US, and said that even though they're using the scan tool to perform the shutdown, they still physically do the measurements.
Yeah.
So we can do that here as well, correct?
Correct, we can do that. Correct. So, switched off the ignition, okay, and now disconnect the green 12 volt service disconnect. This is this green one here, over there. We try, we have a tiny red one, and then we can try out and up to this position, and then it's fine. Not fully outside, it's only it extended a bit. And now we bring the security padlock on it, lock it, and the key by side. Okay. Next step, switch the ignition on again. And the display say HV system de-energized. Now we can be safe that the voltage is below 20 volt. But For the extra safety, we use the instrument, high voltage instrument. We talked before about that we use the right one. Go to the DC measurement mode and bring up in the same way to say live, dead, live. That means we measure the voltage on the 12-volt battery. The most common variance is to unplug the bridge connector for the extra safety. 12.6 volt in the system.
So we know that the multimeter works fine.
Fine. Then we go HV minus and HV plus.
Normally, of course, we'd be wearing gloves here, things like that to do the measurement, but to do it quickly.
And now we have 25 millivolt, not more. Okay?
Go back and test the battery one last time.
And our measurement equipment is still okay. Good. Okay. Now we were prepared. Now we can open the battery. We displayed but when I open the battery, think about it, the relays that you can see in the upper corner here on the edges, there is outside of the battery. But when I open the battery, then are inside. Here is every time power up. Here is not de-energized. I go into the system. There's permanent power on it. A tiny detail, I lose the screw. A tiny detail is these cover have also an extra protection. When one of the students make fun of the system or want to make fun of that, they open the cover without any de-energizing. In this moment, when I release the screws, in this moment the system switched off immediately. So yeah, my screw is behind me. So. Okay, thank you. Good. Now I can open the cover. You can see the cover.
So you've actually integrated the interlock into the front cover there as well.
Yes.
Is that a piece of brass or copper or something there?
It's copper. It's a copper. Okay, now we have here we have an extra cover to protect for contact. The terminals, all terminals have an extra cover, and we need which cell? Daniel, which cell we want to replace?
Was 11.
11, okay. 9, 10, 11. So we have to open this cover. Only 4 or 5 turns. And then we can remove this cover and we get direct access to the terminals. Now we need the cross screwdriver type 2 again. And now we can release cell 11.
And so you can see here that you've also got the insulated mat where you're working on the workbench.
Yes.
Also a good idea if you're working on the high voltage battery.
Especially when you have to to remove the battery, and you lay down on the table, and some metal, or you came, for example, you have a metal frame on your table, or some tools that can connect the terminals, bridge the terminals. So you prevent
definitely
that.
no metal, wood if possible, but wherever you can, use the insulated mat.
Yeah. Short before we start with the video, you asked me, is it really a battery? Is really a battery inside?
Okay.
Now we can check it out.
Yeah.
We start with DC voltage and measure .04. Okay? You see, in the time when we worked on the system, the voltage level decreased a bit. We are 2 digits behind the point, so we are in the range of 10 millivolt. So in this case, you have, it's possible that there are tiny difference between each cell, and over the time, when we stopped, we have 0.9, and now we goes to 0.4. So this tiny difference are not so, it's not a problem, but when you have different more than 100 millivolt, then
can be a problem.
And this is the reason why we balance.
So let's just go and have a look at the balancer for a second now and just see how that's progressing.
Okay.
So it's actually in the last section there, but Bernd, I think you were telling me you've designed this so that once it gets to the voltage, it actually goes a little bit higher and then does some discharge to remove the surface discharge from what we know from 12-volt batteries. But it's not simply just pushing it up to 4.06. Yeah. There's actually a lot more to it to that. It makes sure it's at the exact
we saw it before. When we charged in the system, we goes up to 4.15, then it starts balancing. When you stop charging, it goes down up to 4.9. So in this system, we have all the time, we have to charge, stop the charging for a millisecond discharging, and then measure, okay or not, and then goes on. And this makes he 4 or 3 times, so you can see we are...
Is that what the indicator light is showing? Is that the certain charge-discharge process? Is that
that is the working. You can see it by the digits in the front. In the front is 1, means it's charging, the first letter here, directly on the edge. And you can see that for a short moment that goes into the 4, it's discharging, and then needs a break, a short break, before they start measurement. Charging, discharging, make a break, and measure.
And so you can imagine if you just put the battery into the vehicle, it's going to have to try and do this as you're driving the vehicle. So to try and get it balanced to that point. Yeah. And that's why we need to do this externally. It's really, really important. So
to do that, yes.
I think you were telling me one time that if you put in a cell, let's say a half a volt or so, it could take weeks for the battery to get balanced to the right place. Yes. And it's going to be pulling up fault codes, and generally it could even damage, maybe not damage, because if you've got the balancing occurring
get under trouble, it's warning all the time. And for the customer, is it not a good feeling? I paid a lot of money for change my cells, and the system is for days, for weeks, permanently warning.
Yeah.
So, and also in the real car, we have balancer, huge balancer for huge cells, and this balancer cost thousands
in the workshop.
In the workshop,
in the workshop. But the balancer inside the vehicle is working on.
The current is not 100 milliamps around.
So we've shown you the video before, look like big, as you said,
Yeah.
switches with a big resistor, but
We-
the resistor, if you look inside the balancer of an actual vehicle, it's very, very small, isn't it? It's like,
Yeah.
it's tiny little surface mount devices.
Oh,
And there we go.
there we go. Yes.
So lots of SMDs inside the,
Yeah. You have a lot of
balancer.
cells. When you balance a lot of cells in the same time, you heat up the battery. And you don't want to heat up too much, so you can't balance too much at the same time.
Okay,
Yeah? Okay.
very good.
Good.
Okay, so
Now-
cell is now balanced. Please remove the cover and the cell.
Okay. You can do now. So I do it with gloves, so I can bring it directly up into the system. I think it's really self-explaining with the display information that you need to remove screws. And now,
And just to tell you what a crazy guy Bound is, he actually developed this in his basement at home.
don't talk about my secrets. A tiny thing is, we have an extra secret. Each battery module have an own BMS, a cell BMS. So when the students want to make such fun with this cell, it's the wrong cell to make fun. When you want to short circuit this cell, they switched off internally the 6 amp electronic fuse inside. You can't overcurrent the single cell. So we have also protected each cell itself and the BMS that you can find also in the car. But here is extra safety inside. And for the fault switching, we have behind a tiny connector. And in the tiny connector, it's the digital coding for the cell number. Now we replace number 17. And also the fault switching are here inside. Okay, good. Now we can replace the cell. We get our screws. So please be careful. The first screw only, not fix it complete. The screw a bit released. Now you have the possibility to bring it in the best position, the battery module. And then when you fix the second screw, then you can also fix the first screw. Okay, bolts are fixed, and now we can bring up the cover back to position. Yeah, maybe I can explain before we make the cover on it. We have also the temperature sensor here in the system. That's also easy to replace this sensor. Maybe later we get a problem with the temperature sensor, and we can do it in the same way. Open the cover, de-energizing, open the cover, and also we can replace the temperature sensors if it's necessary. Not now, but maybe later. Okay, good. Everything is fine. Now we can bring up the cover. So 1, 2, number 3. You can see it's not easy to work on the screws with gloves, but it is possible. So 1, 2, 3, and 4. The swapped cell is inside, the terminals are fixed, and the cover is also on the right place. Okay, by side. Okay, what can be the next step? Daniel, what we have to do next?
So should we test the vehicle, re-energize and...
Re-energizing, good idea. Oh, I start with the padlock. Now I have to bring up. Okay, so we could see before we can only easily bring it with the finger, pull it out, but it's protected that we can't re-energize without a tool. We need a tool to re-energize it. Yeah, it doesn't work, it's an extra safety, and the screwdriver, only tiny flat head screwdriver, only in the hole, straight ahead, and nothing else. Next step, we bring...
And just as a reminder, you don't actually need the gloves at this point because the system is low voltage, but...
Okay, you're
Do you
right.
want to tell the story how you found out about this switch found, or should we leave that?
I don't know what you mean exactly.
Okay.
Well, I think it's a good idea. This connector is common use. This many cars are built in this disconnect plug, and often I can hear they damaged this plug. Especially when you want to bring it in and it stocks, you go with high pressure on it, and then the plastic breaks.
It is very fragile, I must say.
Yeah.
But if you know what you're doing, there's actually not much.
So, okay, screwdriver inside, and you can feel there is a tiny wing, a plastic wing here on the lower side, and when you bring the screwdriver in, you can see they came out. I think. Can you catch it with the camera?
Just underneath we can see.
Can you see that?
Yeah.
Okay. That is enough. Then press on the red button and then you can go easily inside. Press it completely in, and the last point is press the red button. And then it's fixed. Okay? Good. And now we have to switch on the 12-volt battery. I think we need that. Okay, ignition on. So, high voltage system de-energized. Stop. Oh, okay. You want to share the screen? Okay. The high voltage system is now insulated. Please fill out the documentary and the records if you is it necessary. Oh, sorry. No. That was the last step. And now the important sentence, leave this page will reset the disconnection procedure. It's also an extra safety. You can switch on and off.
Doesn't matter.
It doesn't matter. You have to leave this page before you can restart the system. Okay? So. Now we start the system. Okay. Next. But we have to erase the fault codes.
Mm-hmm.
The lamps, the orange is still on. We out. Yeah, okay.
So
12-volt terminal, we disconnected.
got a lot of errors coming in here.
Yeah, coming up. Okay. Read out next.
No faults.
Okay, and the HV fault lamp is off. Okay, now we can start with system values, and we saw the problem in the monitoring without load. If you can see, our cell is still broken. Okay. Did we use the right cell?
Well, that's usually what happens when we have a...
Reset.
Did we keep the fault on there, maybe?
Oh, it's okay. Fault reset. Okay, we forgot it. Fault reset.
Let's go back and... Looks a bit better. We accidentally left the fault inside.
Okay.
So that looks a bit better. So now
Yeah,
we can
looks better.
see that the system is acting as normal. You can see there's still a little bit of a difference there
Yeah.
within that cell, but it's certainly much better than if it was a long way out of range.
Okay.
Okay, so
Good.
Bernd, you mentioned before about some temperature faults as
Yeah.
well. What the problems might be if there was some faults within the temperature in
Yeah.
the system. So
Yeah.
we know that that could cause some problems with the vehicle.
Yeah. 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 When we show, we can go into the workshop order. Oh, the workshop order. I click in the workshop order 2. Now we became a statement from the customer. The customer brought a vehicle to the workshop and they're complaining about the HV fault. And the good thing is here we only have to click on the job order and then the system set in this situation. And that
So
corresponds to the problem that the customer talk about.
So what we're doing here, which you might not have seen, is we're put in the faults over here. So it's kind of like as the student goes in through the different pages. I just noticed that we clicked on a couple of different ones there, bound. So I'll go back to number 2 there. So, sorry.
Okay.
And because it is a real system, let's
Yeah.
just delete those faults, because as we've seen before, the faults will perk up all of the different codes.
Okay, and read out again. Okay, the customer came in, complained about the lamp is on and the car is much more noisier than nominal.
Exactly. And so what we did just there was, as you do in the workshop, you read the codes,
Yeah,
delete the codes, and then read again to make sure, okay, are these hard faults or soft faults? And so here we're seeing, okay, temperature fault.
Okay,
You can also see that on the system here.
yeah. And we get some extra information. Can you click on the arrow on the right one? We have fault codes 1 from 2 after erasing sensor 5. Okay. Okay, we get an information. We have trouble with sensor 5. And now let's show what the measurement we can show. The BMS ask, okay, temperature sensor 5. Okay.
So there's a clear problem with that one there.
Yeah.
But
Okay.
that comes back into
Yeah.
something that we also need to take into consideration. What type of fault is this? This is really important when it comes
Yeah.
to the workshop, and especially hybrid electric vehicles.
Yeah. You have to classify it.
When the vehicle comes to the workshop, you need to make a decision, because as we know, the vehicles can catch on fire.
Yeah.
So you really need to think about, shall I be driving this vehicle inside the
Yeah.
workshop, or shall I leave it outside? And so there's a little bit of a, what we call
It's really important, the decision.
the stoplight decision tree, for example.
Okay, good. And in this case, we can go to the temperature.
Do you want to
Okay,
talk about what they...
yeah, okay. Yes. What Daniel mean is we came up here into the orange state was orange, and then we have to decide, can we go to the green and drive into the workshop, or we have to stay outside with the red condition. Which condition we have? We start in orange, unclear, and then we have to decide what's happened. So for this procedure, we haven't followed, we have this state, and we have a temperature problem. And in this case, we can search for the section with the, you closer to. Okay? And the meaning behind, in this situation, we have a high critical situation, we have a hot spot, and the heat comes up to the other.
It's radiating out of one hot spot. So that's something a lot of firefighters, they'll use a thermal camera, for example, and use that on the car and see if they can see a hot spot inside the battery.
Or maybe we have an uncritical situation that is only a red dot and no radiation. All the others say everything is fine.
So that's kind of pointing to the fact, is there an actual, we can see here with a highly critical fault,
real overheat.
That would most likely be a real high temperature in the battery. But if it's just in one position, one sensor, which is what we looked at before.
And now we can compare this situation here, or have we this situation.
So I think it's pretty clear that that would be a non-critical.
Non-critical.
So in this case, you would drive the vehicle in and then you could work on it. But definitely something that's very important, if you've got a temperature fault within a high voltage vehicle, park it outside. Do the testing first and then you can take it inside. You don't want the car catching on fire inside your workshop. That's the point.
Yeah.
Okay, so perhaps, Bernd, if you can just have us show us a diagnostic procedure for a temperature fault here. We won't worry about pulling the whole battery apart again, but what would be a diagnostic strategy for doing that?
That is the reason why we have tiny connectors here. We have here tiny interconnections from the BMS and to the wiring of the temperature sensor. So we can switch off the ignition and disconnecting these bridge connectors. Now we have directly access to the sensor inside of the battery. Okay, and now we can also use Daniel, maybe you can find the page with the resistance curve, the resistance curve of the temperature sensor.
Sure.
Now, what we try to do is measure again.
This one?
Yes. So we have around 20 degrees. I make a knot. So what we expect is we measure. We are now in the range of 20 degrees here, and in the correct version we have 10 kilo ohms. That was the correct value. So now I go to the measure point X1 to the X2 and measure directly during the wiring up to the sensor, and now I can see the resistance in the sensor. Yeah. I have there's a second possibility. I can choose a second sensor. There's a second wiring, and can measure the other one here over there. Sensor. Measure on this side. Here's the second. We have in total we have 8 sensors. The second sensor goes here, and there was no complaining about this sensor, and this is for me the reference. So, and here it's, Daniel, can you see that? It's 10.6
kilo ohms.
Okay, that is that matches to our table of temperature sensor, and the other one was 1.2. Okay. And this resistance is definitely too low. So we have here a problem in the wiring or in the sensor self. And then when we can say to the student, stop, up to here is good. It's enough. Diagnostic stopped here. But now the specialist has to open the battery cover again and to measure the sensor itself or the wiring.
Okay.
Okay?
All right. So that's just a small introduction into the battery there.
And you can scale that. You can say, okay, it's enough to find out it's critical or non-critical. It's enough for me for the first step. Or I can say, please measure, is it really a problem with the wiring? You can measure up to here. Or you can go deeper inside and say, okay, fix the problem and check the sensor.
Okay, so just delete all those codes there. I will go out of the diagnostics as well. Reset the faults. So what we'll have a bit of a look at now, we're actually, as we mentioned, what would probably happen at the start, we would run out of time, but we're still having fun. So we're going to continue on. I'm going to have a look at a couple of different sections. So system main relays.
Yes.
And some of the faults that we would see in system main relays. So last night we had a brief look at how system main relays work and what their operation is, but we're going to also have a look at how they work in detail this time with some diagnostics. So what happens when the pre-charge relay is working, when it's not working, things like that, just some sort of common faults.
Yes, we can do it now if you want.
So we'll have a look at that, but we'll also, that will include things like active and passive discharge.
I only check out system, okay. Active and passive discharge, yeah. Oh, I think it's fine. Okay.
Okay. So
fault free now. Good. Yeah, we can, at first we have to connect our measurement device with the system relays and the high voltage system, that we can say, okay, now we can see what the relay have to do, like before.
So I'll set up the...
So is, in the LabSoft is, you can find the instruction in the LabSoft.
Of course, we're... all of this is shown how to do this in detail. We're jumping around a bit just to show you some of the safe handling.
No, safety.
System main relays. So for example, I'll show you what that looks like, an experiment, just so that you can see what we're doing here. We don't expect you to have to remember all of these components, but this is now showing you to connect up the negative.
Can you stop for me? Okay, minus. The first step was channel A minus to HV minus. Then was the second ground connection to the minus of the low voltage system, of the 12 volt voltage level. And they are interconnected. You can see that on the, oops,
You can see that down here on the oscilloscope input, that all of the grounds for the system main relays that we're going to check are all together.
Yeah. The high voltage is separated, but the other are all connected to the ground. Okay. Then the next step, can you start again? High voltage plus on channel A plus. That was this connection. And channel B was pre-charge.
Pre-charge.
And channel C was main plus relay. And the channel D was the HV minus relay. A lot of wires in it, I think with the guided tour it's possible to follow the explanation. Okay, now we see the oscilloscope. And we have to set up the oscilloscope, so channel A to 20 volt each per division, and B, C and D all together on 5 volt. And also the time, we have to set up the time for 1 second per division to make it a bit slower, to make it more visible. Okay, and in the best way, you see, normally you have 4 different colors for 4 channels, but in the moment you can't see, all in the same area, the
All
other,
at 0 volts.
all at 0 volt. You can make a trick. You can say, okay, one channel, I go only a tiny bit up. The channel B stay on the same level, and C goes a bit down, 1 ticks, on D also. Now you can see all 4 lines. It's better for later.
So the voltage is still at 0, but we've just done that just so that we can see that there is a little bit of a difference.
Okay. Now I want to start the system, the preload and the main. Okay, can you stop for me? Good. Okay, now you can see a lot of things. On the channel A was high voltage, so you can see it start. The condenser is charging up to the point, up to this point, and then it goes to the final voltage level nicely, yes. And it goes 20, 40, 60, a bit over 60, 64 like this. Then we have the preload relay. It only starts here, goes up, and stops a short time before the main relays come up. The main relays came in this situation, the system say, okay, in this position I get a go. Maybe we can see it better. So it's a light blue line is here and switched on the main relay. So we can see the interaction between the preload section and the main section.
So yeah, as you can see there, the light blue is that main relay.
The main relay.
So the one at the bottom here.
Yeah, and the red line is the preload relay. With the preload relay starts the charging.
And the main relay switches on, and as soon as, so and in this case the ECU or the battery management system is looking for that high voltage. Once that's been achieved, it switches off that pre-charge relay, and that's what we call ready mode.
Ready mode, exactly, yeah. Okay.
So
So,
let's have a look then. We'll let that system run a little bit more then.
yeah, it runs, still runs.
So still going. And then what happens if we shut down the system? What do we
Yeah.
see there?
Let's show. We switched off and stop. Great. Okay. Yeah, the red line is preload is gone, but in this case, you can see when we switch off the system, it starts to discharge the condenser. It goes slowly, it starts slowly. And at the second edge, we go into the active discharge. In modern cars, we need an active discharge to extend the safety. When someone goes into the system, goes crazy, open things, that when the interlock stopped, that we only have a short period, that we have full power still on the system. Also,
So this
shut down the system as quick as possible.
And this passive discharge is the reason why in the older vehicles and the older times they used to say, okay, wait 10 minutes.
Yeah.
So you've removed the key, shut down the vehicle, wait 10 minutes because you've got literally a resistor inside the inverter which is discharging the capacitors. So this here is talking about
And that takes time.
the really big capacitors inside the inverter, and this is what we're talking about here. Active discharge, as you said, that's now activating a pretty large transistor in the DC link, so discharging those capacitors, and that's either charging the 12-volt battery or it's being discharged through the windings of the motor. In certain windings so that the motor doesn't turn around. You don't notice it, of course, but obviously the best way is then to charge the 12-volt battery if possible.
Yes.
So that's what a normal signal looks like, and all of that has occurred in less than half a second bound.
So,
correct?
Yes, less than half a second. And now we can show how the way goes when we haven't got any active discharge, only passive discharge. We can do that. Also, we start the tester.
Yep.
Oh. Exactly. The secret. You talk. Okay. Now we get in direct access to the faults. And here you get direct access to any fault that we can switch directly. We can switch all in the same time, but it's not the best idea. We can choose which we want to show. For example, here now, active discharge error. And now we have an old system. Now we change the new system into an old system. To play. Oh, okay, so let's show what's happened. We start again. And stop again.
And so that's the way it used to happen back in the old day with the passive discharge. And this is just for a 60 volt.
60 volt.
So
you can imagine when you have 300 volt.
It takes a lot longer for that to occur.
A longer time to de-energize.
Okay, so turn that one off. And what else do we have? A preload relay error.
Or main relay, don't switch on. That's also a good idea.
Open?
Open, yeah. For the first time it's open. It's also a good idea. Okay. Now we have the situation, we have a trouble with the main relay. Oh, the main relay doesn't work. So when we start now.
See the preload going up. And because that main relay didn't switch on, it's now said, whoa, hang on, something's not right here. We're not going to give the go-ahead to go to ready mode. And
we don't reach the level to get and go.
Yep. And so then it's going into passive discharge. Passive discharge is kind of like a limp home method of disabling or deactivating, de-energizing the system. If it doesn't know, it's thinking something's wrong here, let's de-energize the system with the old methods, using the
especially
passive discharge.
When the plus relay is welded and you want to active discharge and the main relay is still on, and then the system want to discharge the battery. Try. No.
So welding, does that actually happen in real life where the contacts weld together?
Yeah,
it has happened.
It has happened.
Okay.
So
let's see what that looks like then, hey? Would that be?
Okay.
So welding the contactors shut.
Yeah, everything is fine, looks as before, but when I switched off,
Now that's something very interesting there, isn't it? So you can see here the system has actually, let me just get a couple of arrows there, the system has tried to oh
yeah. So
Let's
other
get-
direction,
it's
please.
late in the afternoon here. It's been a long day.
Okay.
So that is where the system has said, okay, we're shutting down, we're going into
Yep.
passive and active discharge mode here, but it's realized, whoa, hang on, the voltage isn't dropping down.
Yeah.
And so it's
They try to do that, but it doesn't work, so it's switched off.
Okay, and so this has been, and Christian actually mentioned this last night, that this has happened, they do a lot of this teaching here, so in order, there's a kind of a qualification that you need in order to get this qualification here in Germany, and they're doing testing and training on this system, so they'll put this fault in, and it's making sure that the students are actually testing, has the voltage dissipated? Because if you disconnect all of the systems, so for example, if you do the low voltage disconnect, but the relays are welded together, you're still going to get high voltage there. So the gentleman that mentioned last night about Volkswagen, they still need a physical test there. It's for those particular situations where you need to make sure that the system has dissipated. And that's exactly what this is for.
Okay. Yes, we have also,
There's a lot in here.
sometimes I get the question why we need pre-charging, why we don't switch really only on, like a light switch, on, off, nothing else. Why we need a preload, and sometimes they talk about the condenser that we need time to charge, but we saw the fuse, how big the fuse, the main fuse is in the high voltage system, and you can imagine what's happened when you have a short circuit in the high voltage system and we switched only on, and there's a big connect between high voltage plus and minus.
It's basically like a short circuit, if I'm...
And you can switch this.
I just wanted to delete all the codes because when you start playing, as we know with a vehicle, if you start entering too many faults, at one point the system will say, hey, that's enough. So, okay. Preload relay error, is that the one?
No, overload. Yeah, HV overload. HV overload. And now we start again. Stop. Yeah, good. You can see the high voltage starts to increase, but only few volt, 2, 3 volt. That depends from the internal resistance, but you can't see, you're missing the complete curve, and then you can't go into the ready mode, and the main switch doesn't switch on. So the system is still safe.
Okay.
Also not only capacitor charging, also check out, is there any unexpected load in the high voltage system?
So there's a lot going on there. We're actually in the middle of developing another system which goes for the next generation. That's also occurring now. So perhaps we'll be able to do a webinar on that in the next 6 months or so. But that's where the checking is occurring at another layer on top of that. So the relays are switching on individually before as well. So it's a really interesting topic, and you can certainly just keep going and going to learn more and more about all of these systems. So Ben, I think that's probably close to enough for tonight. Otherwise we could keep going on and on. I know that you're all got to get to work at some point. One last thing, just wanted to show you here is that you can select all of the different cells and do all of the faults there individually as well. So that's the point of making them digital with all of the coding that you were talking about before. Create open circuit high resistance. Don't recommend doing the open circuit. I did that one time, and just like on a real system, it will actually drop the system state of charge.
Yeah.
Wants to go to 0 because it's recognized that one of the circuits, one of the cells has gone to 0 or to open, and so you'd have to recharge the entire system back to 100%. It needs to relearn the system.
You need to complete, load the battery fully, and then it jump to the 100%.
Yeah.
Yeah.
Okay, so what we might do is just, if anyone has any questions, we'll go back here. If anyone has any questions, now would be a good time to ask us. Again,
now or never.
Now or never. Exactly. So bring up chat. Nothing's there. But apart from that, it's thanks to everyone. We've still got 20 odd people that are here. Thanks very much for staying for so long. We're all a little bit overwhelmed with webinars and working online at the moment, so it's good to have people on a topic like this. It's been interesting.
To make a best out of it.
Exactly.
To make it best. Okay.
Still no chat, so we're going to say good night.
Yeah.
It's late here.
Good night.
It's late here. On a 12-hour day. So thank you very much for coming.
My pleasure.
Along. I know you're not a big fan of doing them too much in English, but you've done a great job.
I try.
So Della, who's helped with all of our
helping hand behind the screens. Come on, turn around.
Big massive help here. So thank you very much.
Thank you. Yeah.
All the best.
All the best.
Enjoy the rest of your day.
Enjoy.